Okay, so today we're going to learn the substitution method for solving linear systems of equations. First of all, as you can see, our definition of substitution is when we substitute part of one equation into another equation in order to find the intersection point. So when we're doing this, we're actually looking for where two lines cross. The first step to doing this, or to doing substitution, would be to solve one equation for either x or y, or really whatever variables you have. You're trying to get one of the variables by itself. Then, after you have that, you can substitute in that expression into the other equation. The biggest thing here is don't accidentally substitute it back into itself, otherwise you'll end up getting that 0 equals 0, because that's always a true statement. So make sure you're substituting it back into the other equation that you haven't used yet. And when you're doing this, you're doing it to solve for the opposite variable. Let's go ahead and do an example and see how this actually works. The example we're first going to look at is 2x minus y equals 0 is one equation of a line, and 3x plus 2y equals 7 is our other equation of a line. Now, going back to our first step of substitution, we need to solve one equation for either x or y. Right away, I see in this first equation, it's going to be pretty easy to get the y by itself. In fact, if we add the y to the other side, we're going to get that y is equal to 2x. After we have this, we can go on to step 2 of substitution, where we plug in this expression, 2x, for y in the other equation. Let's go ahead and see how this works. So we have 3x plus 2 times y, keeping in mind, though, that y is the exact same thing as 2x. We found that out from our first equation. And that has to equal 7. Well, now we have just an equation where we can solve for x because we have only the one variable. 3x plus 4x is a total of 7x. So if 7x equals 7, that means that x must equal 1. Now remember, what we're solving for is an intersection point, though, so that means we need an entire coordinate pair. We only have the x coordinate right now. We need to plug it back in to find the y coordinate. What's the easiest one to plug it back into? That one, of course. So this means that y must equal 2 times x, which we just found out was 1. So this means that y must be 2. This means that the answer, or our solution, would be the point 1, comma, 2. X is 1 when y is 2. Now how can we double check if this works? We can plug it into the equation we did not use. Notice right here we used the first equation when we solved for y. Well, we can go ahead and plug both these values, 1 for x, 2 for y, into the second equation to do a check step. So for our check step, we're going to have 3 times x, which was 1, plus 2 times y, which is 2, and that better equal 7. Well, 3 plus 4 does equal 7, so we're good to go. It checks out. This point is going to be on both lines, which means it's going to be the point that they intersect at. Example. This time, we have this equation, or this set of equations here. Negative y equals negative 2x plus 3, and 3x minus y equals 4. This first equation is actually super close to the y already being by itself, but we have a negative y, so we could either multiply or divide everything by negative 1 to get y by itself. That would leave us with y equals 2x minus 3. Again, we can substitute that in for y in this equation and get everything in terms of x. Let's go ahead and look how it works. 3x minus y. Now because y is an entire expression, we better put it in parentheses so we remember to subtract the entire thing. And then this has to equal 4. Now remember to distribute this negative sign. So we have 3x minus 2x plus 3 is equal to 4. This means that x must equal 1. Again, we need to plug this back in to figure out what y equals. In this case, y is going to equal 2 times x, which we found was 1, and then minus 3. 2 minus 3 is a negative 1, which means that these two lines must intersect at the point 1, comma, negative 1, because x is 1 when y is negative 1. And lastly, let's go ahead and do our check step. Again, we need to use the equation we haven't used yet, which would be the second one here. So we have 3 times x, which we found was 1. And then we have minus y, which we found was negative 1, must equal 4. Well, if we have 3 minus a negative 1, that's the same as adding 1. So 3 plus 1, 4, does equal 4, and it checks out.